In a monumental leap in generative AI, US graphics heavyweight Adobe has unveiled its breakthrough AI tool called Project Gingerbread, which combines 3D modeling and text prompts to provide unprecedented precision in AI media generation by using 5 amazing features. But first, how does Gingerbread stand head and shoulders above other models from Google and Microsoft? Crucially, Midjourney only provides limited control to their customers. And although research projects like DragGAN have indicated the feasibility of precise AI image generation, and tools like Meta's Make a Scene and Project Collision offer more control, none have managed to transcend the limitations of a research lab and break into the mainstream. Basically, the big problem with other generative methods is that the AI tends to put things right in the middle of an image. But what if the user wants to compose things around it? This question captures the essence of Adobe's Motive, an AI tool that breaks free from predictability and empowers designers with the ultimate amount of control, and its key features are as follows. Number 1. User-created 3D scene presets. At the crux of Project Gingerbread's groundbreaking AI suite is the ability to use user-created 3D scene defaults for image generation. Unlike the standard AI procedure of random composition, Gingerbread layers the generated image atop these defaults, providing a dynamic level of control for designers. It's akin to having a skilled artist at your fingertips, ready to create based on your directions. This feature is not just an upgrade, it's a revolutionary shift in AI-assisted image creation. Number 2. Interactive text prompts. The power behind this transformative tool lies in its interactive text prompts, able to interpret commands and shake 3D models based on the user's instruction. For instance, using a simple text prompt like whiskey glass on wooden table, the AI would mold the scene accordingly, placing the whiskey glass where you would have envisioned it. This integration goes a long way in showcasing Adobe's dedication to making AI tools more intuitive and designer-friendly. Number 3. Custom 3D object support. Expanding on its customization capabilities, Gingerbread offers support for user-uploaded 3D objects. This means you can use these custom objects as part of your scene, making AI image generation less random and more personalized. The custom 3D object support stands as a testament to Adobe's commitment to facilitating efficiency and ease in the designer's workflow. Number 4. Empowerment for creators. Adobe continues to empower creators by setting the stage for more accurate AI image generation. It borrows ideas from research projects like DragGAN and tools like Meta's Make a Scene, showing that precision in AI image generation isn't just a distant concept, but a reality. When integrated into popular tools like Photoshop, it signals the dawn of a new era of digital design, taking Adobe's AI from the lab to the hands of designers worldwide. Number 5. Integration into Adobe's Creative Suite. The last feature is Adobe's plan to embed Project Gingerbread into its Creative Suite. This suite, including apps like Photoshop, Premiere Pro, and Illustrator, provides a ton of ways to go beyond simple text-to-image prompts. This integration is bound to enhance user experience, bringing a level of personalization that caters to the unique preferences of each user. Importantly, Adobe is slated to make more announcements about Gingerbread at Adobe Max 2023. And while the company traditionally reserves major revelations for its in-house show, the rapid advancement of the AI industry leaves no room for delay. This urgency likely prompted Adobe to offer an early peek into Gingerbread, setting the stage for a game-changing year in AI image generation. But what about hyper-realistic video generation from text? Amazingly, in a game-changing move for synthetic data creation, researchers from Princeton University have recently rolled out a groundbreaking procedural generator of photorealistic 3D scenes called Infogen, which aims to address the limitations of existing synthetic datasets, primarily their restricted diversity and failure to capture the intricacy of real-world objects. So what does this mean for the future of synthetic data, and what makes Infogen so special? Infogen stands out as a fully procedural system, capable of creating an infinite variety of shapes, textures, materials, and scene compositions from scratch. Its unique selling point lies in its production of high photorealism levels by procedurally generating geometric and textural details at both the macro and micro levels. It pushes the boundary by basing all its geometric data on real-world references, thereby enhancing the authenticity of the synthetic scenes generated. But how exactly does this novel system accomplish this feat? Infinigen's extraordinary capabilities are not a standalone marvel. At its core lies the power of Blender, a recognized graphics system. The system's architecture is built upon Blender, a renowned graphics system known for its prowess in procedural generation. The Princeton team has designed and implemented a library of procedural rules, thereby expanding the coverage of natural objects and scenes. Leveraging useful primitives available in Blender, these rules unlock a world of naturalistic graphics. But the team didn't stop there. What were the additional features they added to facilitate this process? Beyond its Blender-based architecture, Infinigen shines in its innovative approach to procedural rule creation. How exactly does the system streamline the process of crafting these complex rules? In an impressive effort to streamline the creation of procedural rules, the team developed utilities that transform Blender node graphs into Python code. Additionally, utilities have been created to render synthetic images with ground truth labels, thereby providing essential information such as depth, occlusion boundaries, bounding boxes, optical flow, surface normals, object categories, and instance segmentation. Through its advanced features and mechanisms, Infinigen is setting a new benchmark for synthetic data. But how does this data compare with that of existing synthetic datasets and generators? To gauge the quality of the synthetic data, the team compared Infinigen's output with existing synthetic datasets and generators. The results were astonishing, demonstrating Infinigen's unparalleled ability to produce original, photorealistic assets and scenes without relying on external sources. This offers immense potential for generating expansive and diverse training datasets that more accurately reflect the real world. As Infinigen continues to evolve, its future looks bright with collaborative efforts and open sourcing initiatives. But what does this mean for the wider research community and the future of procedural generation? The researchers intend for Infinigen to be a community-driven open-source project. They envision the expansion of its coverage to include all real-world elements, ensuring its continued development and growth. The commitment to offering Infinigen as a free resource shows the research team's dedication to foster collaboration and inspire further advancements in procedural generation. And the advent of this technology has even wider implications for the tech industry at large. The introduction of Infinigen signifies more than just a breakthrough in synthetic data generation. It's the dawn of a new era in computer vision. Infinigen's introduction ushers in a significant advancement in generating synthetic data for computer vision tasks. Its procedural approach, fused with its photorealistic scene creation capabilities, bridges the existing gap between synthetic datasets and the complexity of real-world objects. This invaluable tool for training models in various computer vision applications paves the way for a future where AI more accurately interprets and interacts with the world around us. Stay tuned as we continue to follow the transformative impact of Infinigen in the world of AI and beyond.